In previous classes, we have seen that how to create the RDD. And in creating RDD, we are having two kinds. One is we can give the Python list. And second one is we are giving the file, text file. So these two things we have observed. So today we will see how to save that file. So before going to that, I'll like if you are saving any file, we already know that if you are considering big data is nothing but we are distributing the data across the nodes. That's what the big data, right? So we are having multiple nodes as a slave nodes, and we are having the master node in the Spark architecture. So each and every, like whatever the distributed data that is given to the slave node, so it has been processed by the slave node, that we know. So if now I'm saying um, partition means, suppose we are having 8 bags, okay? So just I'm taking one normal example. I'm having 8 bags, suppose. So these 8 bags can be how many resources we require to move these 8 bags to here. Like suppose if this is Spark and this is a warehouse. So you want to move this to this, then how many resources we require? We require 8 resources to move this. 8 resources. 8 people we require to move each bag. So 8 resources. This can be moved to here, to warehouse. So this 8 bags can be moved to the target. So how many number of partitions it is going to be taken? 8 number of partitions. Here we are having 8 bags, and 8 bags are moved to the destination, or 8 partitions are moved to the destination. Destination is nothing but warehouse. Which we are having 8 partitions inside this. This can be moved like this by 8 resources. Who are the resource here? Here the resource is the node. Slave node. Slave node is going to, we know, right? This 8, you will get till 8 like this. Here you need to understand one thing. The piece of code is nothing but we are considering this as job. Job to stages. Stages to tasks. Each task is given to each node. So here I'm saying each partition is nothing but each partition is given to each task. The task can be given to the node. So who is working on the data? Slave node is working on the data. This much you need to understand. So what we are doing is we are having two kinds of saving the files. Before going to that, so It's okay. I'll come to that. Actually, I want to explain you how the data engineer is doing, how the data scientist is doing, what is the role of data analyst. We will see in the after some classes also. But here, this is what we are understanding. So we are having two kinds of saving RDD. One is you can save as RDD dot save as text file, right? This is one of the method to save it. And second one is RDD dot save as pickle file. What is this pickle file? We'll see now. So what happened when you are considering pickle file? Here you need to understand serialization, deserialization will happen in this pickle file. So what happened is whenever you are giving, you are saving RDD as pickle file, what it will do is it will collect the data as in the serialization form, like it is collecting the object into the bytes. Okay, then again, when you are saving or when you are retrieving the RDD, you are getting that in the same stream of bytes. Only thing we need to understand is serialization, deserialization will happen in the pickle file. Serialization is nothing but which is converting the number of bytes. The total data is converted into number of bytes. This is the backend work. Actually, we are not able to see anything in this. So pickle file, it is storing means it is storing in serialization, deserialization mode. So this much you need to understand because we can't demonstrate anywhere this thing. So this is the background thing where we are using for the pickle file. Whenever you are using save as text file, the partition data is going to be saved, right? So these two are the main differences between pickle file and text file. So now let's try to save one data frame we have already created. Now just I'll rerun that. So one more thing in normal words, if you are saying serialization, deserialization means it's coding, encoding. Whenever I'm saving the file, it is going to be deserialized. Deserialized is nothing but decoding the file. So to read the data from pickle file, deserialization or creating sequential or serialized data file. That's what we are doing. We are creating one serialized data file. Serialized is nothing but we are converting the data into number of bytes and it is streaming through the database. How to see the RDD by using collect. Meanwhile, if it is going to start, we need to understand what are the actions we have. We have already, I think we discussed that rdd.count, collect, all these things, right?
Yeah.
Yeah, we have discussed that. So it is taking some time to start the cluster. Let's go to the transformations. Meanwhile, if you see like so these are the transformations actions which we have already discussed on the RDD. Okay, so these are the actions. Why we need action? Until and unless an action has been triggered on the transformation, nothing will be happen. It would be sit in the ideal state all transformations are connected together and waiting for an action. What is that? That is called as no, lazy evaluation. Yeah, lazy evaluation. What is lazy evaluation? All transformations are connected in ideal state
until unless we perform action.
until and unless an action has been triggered on the top of them. This is what the lazy evaluation. Even Python is also lazy. Python is also supporting lazy evaluation. So one more thing from the Python languages, it was like, interpreted language, you can say. So whenever we are saying the interpreted language, what is happening is, if I wrote some code here, okay, suppose if I wrote some code, some XXX, this is just, I'm just giving an example. So this is what I'm writing, some code here in the Python. What happened is, suppose if this particular line of the code is failed, okay, due to some error. This particular line of the code is failed due to some error. So what happens is, generally in general compiler, what it will do, it will stop here, right? So if you write piece of code, suppose some 50 lines of code you have written, and in that 50 lines of code, suppose 12th line is failed. What will happen in general compiler? In general compiler, the process would stop at that particular point. So if the 12th line failed, after 12th line, it won't execute anything. But Python is not like that. It will keep aside that 12th line and remaining lines are going to be executed. That is what called as interpreted language. So whenever you are dealing with Python, Python is an interpreted language. You should keep it in that mind, but it won't display anything. But from the starting to ending, the code will be run. That is what the code is going to run. That is what the interpreted language. And Python is also supporting lazy evaluation. Lazy evaluation is nothing but whenever you are giving the transformations, I can give you a small example by that you can remember. Okay. Suppose if you are having a train like this, what will happen? See, this part, until and unless this engine has triggered to on, all these compartments will be connected and kept in the ideal state. Whenever it is going to start moving, then only remaining all compartments are started moving. That's what you need to understand. This engine in the train is nothing but an action. So whenever the action has been triggered, all the transformations are going to be executed. That's why even you have created more number of transformations and everything you executed, it never throws any error. It will take, but you will get the error, exact error, when you try to call that by using an action. So whenever you are trying to call that transformations by using an action, then only you will get all the errors, because the compilation will stop until and unless the action has been triggered. It is like that people will think it will compile, but it won't produce anything. But it never compiles anything. It will keep in the ideal state. When you provided an action to that what executor, then only it's going to be shown the execution part, how it is working, whether it is working or not, we are getting errors or not. We will see that. No worries for that. So how many transformations we are having? Transformations we are having two, right? Two transformations. One is narrow, and
Wide.
second one is wide. Very good. Wide transformations. So wide transformations where we are having exchanging or shifting. exchanging or shifting the data or shuffling the data. This is what you need to understand. Shuffling the data. So shuffling the data would be happen in the Y transformations. So when we are seeing the map reduce function, then you can see the all aggregations, right? Here when we saw that, we see the shuffling exactly what happened. See, whenever we see the slide, we came to understand that my voice is audible only, right?
Yeah, Divya.
Yeah.
Yes.
So if you want a little bit louder, let me know. So this is whenever you are taking this input and what is happening here, you can see all the shuffling is happening. Shuffling is nothing but what you are having data collected at one point. But this data, whenever you are seeing a block, you remember that that is a node. Okay, it's not a block. Whenever you are seeing this kind of image, you need to remember this is a node. Which node? Slave node. So on the slave node, what is happening? This input data is going to be changing the nodes, right? Here in the nodes, what is happening? Welcome to Hadoop is taken in one node. But whenever you calling this in the shuffling, what happened? The nodes, the data is shifting or shuffling or exchanging the data here. This is what the shuffling. Don't what confused with this. Even in the interviews, they will ask you what is nothing but shuffling. Okay, you are saying wide transformations, narrow transformations. What is like a wide transformation? You are having shuffling. What is that shuffling? The shuffling is nothing but you are loading the particular data or you are transferring the data into different nodes. So in that, what is happening? Exchanging of data is happening in the nodes. That is what shuffling. So wide transformations encourage shuffling. That is why if you are using shuffling means what will happen? It will become automatically costly, right?
Correct.
Why? Because we are giving into more number of nodes. Nodes are nothing but what? In memory. Am I right? So whenever we are saying a node is nothing but in memory. In memory is nothing but what? RAM. So
Yeah.
you are working in the RAM. So RAM cost would be more than the disk. But now it is somewhat reduced, but it is costly. Narrow transformations, what will happen is this shuffling, it won't be there. It will directly come to the executor or node. So no shuffling, only one node. In that node, it is going to be processed. That kind of transformations are nothing but narrow transformations. I'll give you some examples so that you can. So whenever I'm saying wide transformations, shuffling. Okay, so give me some examples where we are using group by, order by. So what is order by? Order by is nothing but sorting, right? For sorting also, we require more number of nodes. Order by having. And whenever you are doing the aggregations, fifth one, window function. We will see all these things in PySpark. Window functions. So window functions are nothing but dividing the data on top of window. So these are all the wide transformations, and narrow transformations are nothing but there would be no shuffling. We have already discussed one diagram, but I'll show you again. So we already know that when I'm coming from Bangalore to Hyderabad, then what I'll do, I can come directly by bus or any transport I'm using, I'm coming directly. So is there any not getting down and all these things, right? So I'm coming from Hyderabad to Bangalore. So here, this kind of transformation is called as narrow transformation. straight one. No shuffling, nothing. Only one node is used and it is stored. That is what narrow transformation. But I'm having a pickup point, or I want to deliver some goods. I want to take from one of my friend, and I want to give that to in Bangalore, one of the friend. What I need to do? I need to get down at Nellore. And again travel to Bangalore. What is happening here? Here, this is nothing but Y transformation. Some point where I just dropped at Guntur, maybe anywhere. I took that parcel and I have given to that Bangalore guy. What is this? This kind of transformation is nothing but Y transformation.
So it becomes wide because it's cut short somewhere along the way.
This became wide because if you are, suppose I'm doing group by, SQL, right?
Yeah.
SQL. So I'm doing group by, I'll explain you
Mm-hmm.
technically only. So whenever we are doing group by, what will happen? All the data is grouped, right?
Mm-hmm.
All the data is grouped accordingly. So for that, what will happen? Group by depending on any, suppose if I'm using, I need to group by any column. Okay. So what
Whatever
happened is this,
classification, yeah. Mm-hmm.
any other column. So this column data, I need to get this one like that, or I'm giving some condition for that. What will happen? This grouped data is going to store in different node. It is not possible to store in the same node. So I'm having data here. This data I have given the group by condition. What it will do? It will separate, right? It will separate into, so the condition one and the different data. So what's happening? This complete data is moving to two nodes. Again, this node also can be divided into multiple nodes depending on your condition. What happening? From one node to, it is divided into two nodes. So the data is transferring to two nodes. So what is happening? Some staging is happening here. Some staging is happening. After doing this group by, it will give you to the compiler, and you can see the data here. What is happening? In this two nodes, it is working your query and it is giving to the compiler. What's happening? This data is giving to the shuffling pointer. Shuffling is nothing but it is spreading across different nodes. The data is spreading across different nodes. Suppose if I said order by, suppose I said order by any time, date. Okay, what it will happen? It will collect the date into one node and it will order it and it will store in another node. The same. I get down here, I took the parcel, I again started to Bangalore. Something is happening. It is not, I just sit in the bus and came to Bangalore. That's just straight away, right? But whenever we are using order by, what it has to do, just to take simple example. Okay. Why? Because this is very important to understand. Queries, we can write it, but the concept you cannot. Okay, so here I'm just saying that suppose I'm having a table. In the table, I'm having date column, and in some customer column, item. Suppose I'm having these three. So in these three, I have written a query that select, okay, select star from, suppose this is a customer table. Okay. If I said select star, it is a straight one. You can see all the data at once. But what I said to the query is select star from customer, where Suppose not where customer order by date descending. What it needs to do, it needs to give all the information. Suppose I'm having date 12/06/2005. Again, some dates I'm having like this. What it need to do, it need to take this to another node. That's what I want to explain. I'm having all these nodes. So this information, I'm taking small set of data. This information has to be given to particular node, and accordingly that node has to be descend all these dates. So it is given to another node. Now we are having data here. We are having data in this one node. According to your query, this data has to be given to, it's not directly giving you answer. It will take date column and it will do all the descending operation. It will combine this information here and it will display you. This is what the shuffling. So it is spreading across more number of nodes, the data to get processed, spreading across different nodes. Different nodes is nothing but different in-memories. So you are doing in the in-memories. What will happen? Shuffling will happen. The data are going to be shuffled through different nodes. This is nothing but where you are using the shuffling. Shuffling is nothing but wide transformation. We will see that when we are executing the code, then you can understand. I think cluster will get ready. So it is ready. And we have seen, like, I just creating one RDD file. Okay, I'm just executing this. You need to remember, once you off your free edition or your cluster, what will happen is in paid version, it is not like that. But in cluster, wherever you are using free edition or community edition, what will happen is once your cluster is off, everything is going to be erased. So it is not there. And only thing you can see here is in the we have created this customer DB, right? Only databases would be available and the tables would be available. Wherever we are storing the data is going to be available. But this transformations or this actions, whatever we are doing, all that is going to be erased once the cluster is off. So you need to keep in that mind. Okay, I just created that RDD by using text file method. Okay, from where I got this? From the, just they have given some free data. So I'm getting this through this data. I'm copying here. And I'm copying the path and I'm giving here into the text file. RDD equals to sc dot text file. So from here I have taken, I copied this path and I pasted here. That's it. So I'm creating one RDD. So after creating the RDD, what we need to do, we can save, right? So I just want to save this RDD file as text file. And we see that get number of partitions and glom function. So glom function, what it will do, it will give you how many number of partitions and data it is taken, that will be given for you. And get number of partitions will give you how many number of partitions the file is going to be divided. And how many number of partitions it is going to be divided. By default, it is 2. Why? Because the block size is 128 MB. If the file is less than 128 MB, then it's going to be divided into minimum 2 number of partitions. If it is greater than 128 MB, accordingly, it will divide the data. So now what we need to see is, we need to how to save the data. What we are having, RDD file, RDD underscore file dot save as. You are getting everything. See here, save as. I just want to save this as. We can save in two methods. One is text file and another one is
Pickle.
pickle file. I'm giving save as text file. What I need to give inside, I need to give the path. I'm just mentioning RDD underscore data. Text. Where it is going to store, let's check. I have given the path and it is stored. That's it. This RDD is stored in this in-memory path. Sorry, no, RDD would be stored in your compute part. Wherever you are using, it is stored over there. So the data will be saved in default how many number of partitions? Default 8 number of parallel partitions are going to be saved if you are creating RDD. But if you are taking text file, default it is creating minimum number of partitions 2.
2.
Yes, 2. And again, I'm just saving this. Okay, saving this into the particular path. This text file, I'm saving this into this particular path. And next, I can save this as pickle file. So to save this as pickle file, I already have RDD underscore data, or I'm taking the same one, RDD underscore file. This is my RDD. I'm just using save as pickle file, giving same like path before how I have given, I'm giving the path. RDD underscore data. Just numbers or text file. Just for pickle file. So how we can see this, whether this RDD is created, means what we are doing, we are saving the RDD. What is RDD? RDD is having this data inside. This data we are having in the RDD, right? We have seen this. So we need to check this data is saved as file or not. How we will check? We can check like this, percentage fs head, and I need to give the path. Illegal RDD data text file and pickles. We need to check this by using percentage fs head. It's not giving. So it has created already. I want to call that path. Just by copying and pasting this path, it will give you. It's not giving. Okay. It has saved in this path. It is showing it. So we can see that. One more thing. I'll look into that part. Okay, so whenever we are trying to save this, you can see here this or there would be the number of Spark jobs, right? You are able to see this number of Spark jobs. So for this, actually what Gloom function I have not executed. So if you open this Spark jobs, and one more thing for your paid version, you are not able to say this in your office because they don't allow you to see your Spark jobs. They will hide you. This you are not able to see, but in your free edition also you are able to see this in your community edition also. So how to see the Spark jobs? We are seeing it. You can see here we are having how many number of stages it is there. Stage 2 is completed. We are having only, it is a straight line you are seeing, right? You are having, we are collecting that how many number of stages we are having. 2 tasks we have completed. Like this, you can see any shuffle read and shuffle write happened here. No shuffle read, no shuffle write happened in this. So if no shuffle read, shuffle write happening, which kind of transformation this is? This transformation is narrow transformation. So whenever you are looking into this, if you are not having shuffle read, shuffle write, that kind of transformation is called as narrow transformation. Even you can see it here, right? And this is where it has stored here RDD file save as text file. I have given this, but I don't know. I'm not able to retrieve this due to maybe which part. We will see that. I'll look into that and I'll let you know. Do not waste time on that. So now shuffle read, shuffle write. So all these are narrow transformations. See here, no Spark jobs are there. It's just querying. So here you are having Spark jobs. Collect also narrow only action, right? This is action. So all actions or comes under single stage. So it is not going to store anywhere the data. No node is acting on that. Just an action we are calling the data. That's it. But RDD creation is nothing but this is RDD creation is transformation. You can see that. But why you are not getting any kind of Spark jobs here? Any why we are not getting any kind of Spark jobs?
We are
Anybody?
not calling it.
Because we are not having any action on the top of it. It has not executed. If you create any action on that, then only you will get Spark jobs here. Here you are getting, but here no Spark jobs. We think like it is executed, but it will just check the syntax. It will just check the syntax. That's it. It won't execute it backside. Only checking the syntax. But it is not executing. You keep in that mind. If you are not calling any action, it is not executing. So it is not executing. And I'll come to this part in the next class because time is running short. So we are having 2 kinds of saving. One is save as pickle file, another one is save as text file. In this, you are not able to see any background thing. Save as pickle file is nothing but where you are having serialization and deserialization. Deserialization is nothing but you are making this
Encoding.
pickle file into decoding. Very great, good decoding, deserialization. I just want to tell you, I'll go a little bit slow and we will take more number of classes, that is fine. But you understand the basic concepts, okay? I'm not in a rush.
Sure, Divya.
Thank you.
Thanks.
Yeah. So,
We're not in a rush either.
yeah, then that is what some people are like that. They are looking into like a crash course. They need to do this, all these things, right? So, okay. And we have seen that RDD, how to create it. And we have seen by using list. When you are creating through the list, how you can call that RDD, you need to call into a variable, then only you are able to print, otherwise it is not printing. That part also we have done. So now we just see the mapping. Before that, I'll go into one thing. I'm just creating one RDD. James, for you actually Saturday, Sunday, you are not available or how? I don't understand.
No, I'll be available. But it's just mentally sometimes I forget
Mentally
when I'm at
forget.
home. But yeah, but don't worry, I'll fix that. I got the alarm going on.
That's okay. But actually what we thought is we can stop the Saturday and Sunday sessions. But it's okay, we'll continue. We think like for Saturday or Sunday, one day we will do any practical session or any mock interviews like that for completed. That's
Okay.
okay. So I'm just creating one RDD. We know this, how to create this, right? So I have created RDD underscore data. Now I explained, right? How to create that list in Python, right? So
List number.
list I have explained already.
Yeah.
Mm-hmm. Yeah, you did.
Okay, so no need to do that. So I have created one RDD. Here I just using mapping. Okay, RDD underscore data. This is one of the Python concept. Okay, lambda function. I'm just using map. Why? Because map and flat map also comes under narrow transformations. I'm keep on saying one thing and I'll get you through the one example, then you can understand easily. So map, you just remember, we can see the shuffling now. Map is nothing but a narrow transformation. It is not a wide transformation. Map and flat map. So I'm using map. Inside that I'm using one lambda function. This function is from the Python, okay? Using lambda function, what it will do is, I'm taking one variable a, I'm adding this to 20. So what happened is, whenever I do like this, it will, RDD data is a sequence, right? So each one, 1 plus 20, 2 plus 20, 3 plus 20, 4 plus 20. It will add like that. This is a Python function, lambda. So lambda, what it will do is, it will take 1 and it will add that to 20, or if I multiply also, it will multiply to each number or each partition. So if I'm taking A means it is A of 0 index, A of 1, A of 2, A of 3, A of 4, A of 5. It will move like that. Simply like a for loop, but we are giving here lambda. Now if I am executing anything, I can see here, will this execute? This is executed. Have you seen any output? No. Why?
No.
Because we need to give
Action.
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 Yes.
Okay.
Just connecting this. Now you can see that 1 is added with 20, 2 is 22, 3, 23, 4, 24, 5, 24, 6, 26. So this is map function. We can see the spark jobs. How many partitions? 8 partitions. Default 8, right? We can see the number of partitions also. Because why it is created default 8, I have not given any partitions here.
Percentage.
I just not percentage. We can give the
Yeah, yeah.
partitions. So I have
Comma
not
3.
comma 3, 4 like that. I have not given any partitions. So it, by default, it will take into number of partitions 8. How we can check the number of partitions? What is the function we can use for that?
Gloom.
Globe. Okay, very good. So how RDD underscore data dot globe. This is a function. So what I need to do? I need to keep the
Right.
parenthesis, then dot action.
Right.
See, you can see that 1, 2, 3, 4, 5, 6, 7, 8 partitions. 2 partitions are not having any data. Why? Because I have given only 6. It will adjust into the nodes. So which is it?
Okay. So it goes by the default of 8, and then looks at what's in the list, and from
Yeah.
whatever is in the list, it determines where it falls in the
Yes.
partitions.
Yes.
Okay.
Who will do that?
Compiler.
No. Who will do that? It is done by resource manager, right?
Resource management. Okay. Yeah.
Yes. Where these are storing? They are storing into the number of nodes. Right? Nodes are nothing but in memory. So who will take care of which node is available, which node is not available? It is by resource manager for Databricks standalone. So this resource manager will talk to the nodes. Okay, which node is available, which is not. It will spread across. It depends on the compiler, depends on the resource manager. They will manage all these things. And it is not in our control to which node which data has to be gone. That thing should be keep in mind. So we are dividing this, this is by default dividing into 8 partitions. And when I did the, yes, lambda and map, these two are narrow transformations. So there should not be any shuffling. That's what we are looking for. No shuffle right, no shuffle right, no shuffle read happened. Okay. That's what. So this, if you are seeing like this, what is that? It is a narrow transformation. Narrow transformation. Now, let me give the gloom function. The same. I have used lambda a. Let's just give gloom here.
So in an environment where you have a lot of data, is the speed of execution, is that determined by your network, or by the size of the resources you have?
Power off. Okay, I'm audible.
Yes, you're audible now.
Am I
I can
audible?
hear you. Yeah.
It's recording only, right?
Yeah, still
It
recording.
is recorded.
PG, right? It would be like that only. So I can't help with that. So actually, my work mode is hybrid. So I need to come to office for 10 days.
Okay.
What is the output of transformation?
I think it stopped sharing.
My God. Okay. I'll share. Okay. What is the output of transformation? That we need to understand. Whenever we use actions, whenever we use actions, it will return into result set. Whenever we use actions, it will return into result set. So until and unless an action has been triggered, the transformation is not going to work. That is one part. And another part, whenever we use actions, suppose if I use collect action, then what will happen? It will return into a result set. What is result set? Like a variable or collection. You will get a variable or a collection. Is what? Variable or collection. Whenever we use transformation, it will return RDD. Because RDD is immutable. Simple thing. If I'm calling action, you can see here, if I'm calling action, then it will result into list, right? Which is nothing but collection or any variable it can return. But whenever I have used any transformation, what will happen is it will result in result set. Sorry, it will result in RDD. I'm just removing this. I have executed this. So what happened? You can see this RDD. What I have given the statement. Whenever we use transformation, it will return RDD.
RDD.
Means if I'm creating transformation, then it will result into an RDD. But if I'm creating one action, that will result into result set. Result set is nothing but this one. You can see here. This is a result set. And this is transformation, right? Map lambda.
Transformation. Yeah. Mhm.
Transformation you will get as RDD. I'm just removing this gloom function also. RDD. This is RDD. And one more thing you need to remember, even you create data set, even you create data frame, both are stored as RDD only at backend. So all transformations will become RDD. Why? RDD is immutable. Immutable is nothing but what? Immutable is nothing but once you create it, it is not going to be changed. So it is unaltered.
Incapable
So
of change.
yes, if we are saying immutable, if I have created one RDD, that RDD never going to be changed. This RDD data should be the same. That is what immutable. So RDD is immutable. That's why everything, if you have given transformation, not only on the top of RDD, if you created any transformation on data set or in data frame also, at backend, it will be loaded as RDD unit. That's why we are learning RDD. Even RDD is out of date, but everything is storing as RDD only. RDD is nothing but resilient distributed data set, and it is immutable. And one more thing, it is used only for text files and log files. What you understand?
Yeah.
So everything is converted as text file or log file at backend. Okay. This one. Because RDD is immutable. This thing you need to keep in mind always. So if I'm saying result, yeah, any doubts?
No, I was just gonna say if you can add just right there as a quick reminder, studying as whenever we use because RDD is immutable and stored, and then just finish off that statement with and stored as text files and log files. I know you probably have written it before, or just like something to remind me.
Okay. So
Like after that, yeah, right there. So after immutable, because RDD is immutable, And then
Okay,
you can just add and store it as text files and log files only.
okay, okay, and store
Yes, thank you.
text files and log files. It's fine. So this is RDD. This is what RDD. Suppose I'm creating another result set. Result equals to, I'm just taking one variable. Don't mind whatever backside equals to or something. This is all variables. I can take anything. I'm having that leverage. Even I can take anything, but only thing you need to remember that before creating any variable, you should not have number. So that is what the thing we in Python we are having. So I'm just taking one variable. Result equals to RDD underscore data dot. I'm using map function, the same above function. Have you just saying lambda, same function a plus 20. Now what I'm doing, I'm writing this into a variable. I'm just writing this into another variable. So if I'm writing like that, if I want to get the information how I just use result dot collect. Simple. No need to get confused. Just make anything into a variable and just collect it. That would be easy for you.
Okay.
So this is, you can see I have stored this into one variable. Now I want to see this RDD's type. So how can I see? By type of result. I just giving the variable name. What is the type of this one? This is RDD. This is RDD. Let me check. Will throw error or what? Type. This is a list. So this collect function when I have given, it will become list. But this transformation, what we have done here, it is a backend RDD. Hope you understand. Any doubts in this?
Yeah, I think I got it.
Oh, sorry, James, you said something.
No, I was saying, no, it makes sense. It makes sense.
It
Thank you.
makes sense for you. Okay, right. So one more thing, I'm just giving another one. I'm applying filter on the top of this. Same. Filter is also narrow transformation. Filter. How you are using your where clause in your SQL. Okay. Filter. I'm using same lambda function. Yeah, what it will give you? You please tell me. A what it will give?
Even numbers.
Yes. Will this give? No, right?
Con.
Into call action. Why it is not printing? Because I have assigned this to variable. List has no attribute collect. Again, what happened to us?
Call it on that in the above cell one.
Last time we did the same, right? Yes. For RDD creation. So sharp, Sai. 22, 25, 26. We got it. We got here only even numbers. This is what the filter. So whenever you are applying filter, it is also a which function?
Narrow.
Which transformation? Narrow transformation. Am I right? So I'm just viewing this. What a flash memory is I. Remembering everything. So no shuffle right? Shuffle right.
I know.
This is what.
Nicely done.
This is done. So this is what we need to understand. Actually, last time what happened is whenever we are creating RDDs, we are writing in another cell, it was not taking. This is what for today, this is sufficient. And tomorrow we can see the single stage, multi-stage, and what are the white transformations, all these things. And the lambda function, filter function, both are giving you the narrow transformations only. And tomorrow we will see the DAG scheduler, how it is operating at backend. Okay, we can we are continuing for all 7 days, right? That's why I'm ending this session. If you have any doubts, you can ask me now.
Divya, you created one variable, right? Even when we defining the like data frame also will do the same thing, right? Df is equal to
Yes, we can do. Yes.
Then how we can identify difference between a variable and the data or how we will when we will use both at what condition?
There are no conditions. When you are creating data frame, you will create data frame df equals to spark dot, okay, spark
Yeah,
dot read dot.
read
So for
that.
read dot text or somewhere how you are using, that depends. In the next classes we are going for that, but you are not loading that into any variable data frame.
Okay.
We are just writing everything on the data frame itself. And one more thing, how the RDD is saving, it is immutable, right? In the same way, data frame also immutable. You are not going to change any data frame once you create it. So you will create another data frame on the top of it. Instead of using variables, suppose I'm having df, some data frame df. And again, I want to have another data frame. What I will do is, suppose I'm taking an example, df2 equals to df, and on the top of it, I'm working on that. So this data frame, change data frame is going to be stored in df2. df would remain the same, df2 would remain the same. So it is not going to be changed. Both are immutable. Immutable is nothing but once you defined, that's it. You're not able to change anything in the data frame. You can apply transformations and save into another data frame.
Okay.
But there you don't use any variables. Here we are using only to understand the concept. Why? Because if I'm assigning to this one, then only you can know. If I assign to this variable, then only you can understand what is collect is doing, what is the data, RDD is doing, how it is storing all this. For just understanding purpose, I have taken this. Okay. There, when you are giving list, you can display in the DF easily. There is a function called display DF.
Okay.
And one more thing, I'm sharing this daily, whatever we have done, that notebook. To whom I can share? Shall I share it to?
Share it in the group. I mean,
In the group, James is not there, right?
Yeah, I'm not in that group now.
Okay, so I can. So whenever we have today, this is fine only for RDD, but tomorrow onwards we used to have this kind of functions and all. When you are writing, you need to have, if you have this notebook with you, then it would be easy to get practice and all. So I'll share daily the notebook what we have done. Till now we came across all the theoretical part. We didn't went into the working. So whenever I start data frames and all, I'll share daily this notebook with you so you can practice at home. Okay. Yeah.
Sure.
All right.
Thank you. See, your doubt, right? I have created data frame here. Okay? Data frame, and I don't use anywhere. I'll use the same thing, data frame only. I don't send this to any variable. just to understanding that I have assigned to a variable, so that you can see how it is storing, whether it is storing in RDD or it is storing in list or any Python variables. Okay.
Okay.
Yeah. Thank you.
Thank you, Divya.
That's it.